Okay, so we just talked about angles of a triangle. So angles to be kept very different from the sides, which we're going to look at right now. The sides of a triangle. Did I just use purple up there? I don't know. Okay. Sides. Sorry. Okay. The sides of a triangle total to equal what? When you add all the sides of a shape together, that gets you the perimeter. Which, to be clear, is not 180 because we're talking about sides, not angles. Just like in the last unit where you had to decipher, am I talking about sides or am I talking about angles in this problem? You're going to have to do the same thing here. Is this problem asking me about side lengths? Is it asking me about angles? Or maybe it's asking you about both. Who knows? I don't know. So the three sides of a triangle total to the perimeter, not to 180. So my diagram here, A, B, C, my sides. Which means, let's talk about this for a sec. If this is side A with a lowercase, that means that this angle all the way across from it is angle A. Angle B would be over here, and angle C would be over here. That's important to realize. And I'm just going to designate in the picture here that these are angles that we're talking about for those. Whereas these red ones are sides. Okay. So one last little thing, and this is an important kind of a property here that you want to pay attention to because you're definitely going to need it. For three sides to form a triangle, the two smaller sides have to total to be larger than the biggest side. So for three sides to form a triangle, the two smaller sides must total to be greater than the largest side by itself. So let's look at a little example of that because that can be a little wordy. So if I have a triangle with side lengths of, let's say, 25, let's go 18 and 13. Is that possible to have a triangle with side lengths of 25, 18, and 13? Well, according to this theorem or this property, for three sides to form a triangle, the two smaller sides, so let's see, these are the two smaller, right? You agree that 18 and 13 are smaller than 25. The two smaller sides must total, so when I add 18 and 13, that gets me 31. Must total to be greater than the largest side. Well, 25 is the largest side. And let's look at this here. It is very, very clear that 25 is less than 31. Or if you want to write it like in the not form, 25, the two smaller sides must total to be greater. So 25 needs to be, oh my God, I'm being really silly right now. The two smaller sides must total to be greater than the largest side. Okay, yes. So the two smaller sides must be greater than the largest side, which means the largest side needs to be less than the two smaller ones, which is the case here. So, yes, that I confused myself there. Yes, those side lengths can form a triangle because the two, again, you're just restating that property to explain yourself. The two smaller sides add to be greater than the largest. Boom! Sorry, that won't be that painful ever again. Really, really good here. Really, really good problem there.